Welcome back, everyone. We are starting chapter 9 today. This video will cover section 9.1 and 9.2. We are going to be comparing two means, and specifically with sigma known. And that translates to us that we're going to be using a z-test. Actually, let's be more specific. This is going to be a two-sample z-test. And it's z because the population standard deviation will be known. And we're going to have two means, and it's going to be mean sub 1 and mean sub 2. And we are always going to assume that the two means are equal. That's going to be our assumption for our null hypothesis for these. So let's go ahead and start. An adventure company runs two obstacle courses, Fun Dash and Cool Sprint. The designer of the courses suspects that the mean completion time of Fun Dash is not equal to the mean of the completion time of Cool Sprint. Let's fill that in. U sub 1, they're saying, is not equal to the mean of time of the other. To test this, she selects 255 Fun Dash runners, 205 Cool Sprint runners, and these are going to be random samples. The 255 Fun Dash runners complete the course with a mean time of 77.6 minutes and a standard deviation of 4.7. Let's write this out. So this is Fun Dash versus Cool Sprint. So Fun Dash, we have n sub 1 is the 255. Its mean time is 77.6 minutes. And its sample standard deviation, actually, this will end up, we haven't gotten to there yet, but this will end up being our sigma sub 1, is going to be 4.7 minutes. Now for Cool Sprint, n is 205. X bar sub 2, mean time of 76.6. And we don't know that these are sigmas yet, but we will make a big deal when we find out. That's going to be 4.5. Assume that the population standard deviations, and this is key here. Assume that the population standard deviations of the completion times can be estimated to be the sample because the mean size is so large. And our alpha is going to be 0.05. And is there enough evidence to support a claim that they're different? Okay, so let us start by drawing our picture. Get a good idea of what's going on here. And we already agreed that we know what sigma is because they told us that we're going to use the sample ones as the population ones. Now this is a not equal to, which means it is a two-tail. And what was our alpha? 0.05 is up there. So that'll be 0.025. This is our critical region here, our other one. And to find our critical values, we are going to use inverse norm. Let me rewrite that down here. And inverse norm minus 0.025. Let's see what we get here. So we are getting about negative 1.96, and inverse norm of 1 minus 0.025 is positive 1.96. All right, so we have our critical values. this is going to be a z test statistic. And once again, we are going to run a 2 sample z test. So here we go, stat, tests. And we can see number 3 down, it says 2 sample z test. And we do not have raw data. So we're going to get our first standard deviation, which is 4.7. Our second standard deviation, which is 4.5. And x bar sub 1 is 77.6. And n sub 1 is 255. X bar sub 2 is the 76.6. 6.6. And n sub 2 is 205. 205. This is a not equal to. And here we go. There is our z. So our test statistic here is going to be z is about 2.32239. And we're using the critical value method in this case, although I am going to write down that the p-value is 0.0202, even though they don't ask for it in this case. We have already found our critical values, negative 1.960 and 1.960. And I'm going to notice that my z is definitely in we're definitely in the critical region. And we can see that the p-value is definitely less than 0.05. Either way, we are going to reject the null hypothesis. So can we support the claim that the mean completion time of Flashpoint is not equal to the mean completion time of Cool Sprint? Yes, we can. Because we're rejecting the null hypothesis, we're going to go on the assumption that they're not equal. I'm hoping you're starting to notice that these are all kind of the same over and over and over again as we're looking at this. So here's our next one. A random selection of volunteers at a research institute have been exposed to typical cold virus. After they started to have cold symptoms, 10 of them were given multivitamin tablets formulated to fight cold symptoms. The remaining 10 volunteers were given a placebo. For each individual, the length of time taken to recover from the cold is recorded. At the end of the experiment, the following data is experiment. So what you will need to do is put this into list 1 and this into list 2. I want to point out that I have already done so. You can see the 3.9 and 2.5 for the first list and the 5.6 and the 6.4 for the second list. You may need to take some time to pause this video. I'll have to make sure I didn't change something by doing that. You may need to pause this video to put this data into there. Continuing on, it is known that the population standard deviation of recovery time for a cold is 1.8 days when treated with multivitamin tablets. And the population standard deviation recovery time for a cold is 1.5 days. When treated with a placebo, tablets, it is also known that both populations are approximately normally distributed. The researchers claim that the mean recovery time, mu1, of the patients treated with the multivitamin is not equal to. So let's do our null hypothesis. They're saying that it's not equal to. And is there enough time? And I want to point out that they say that the population standard deviation of recovery time are here. So these are this is why we're going to be using a z-test in this case. So here we go, z. So let's write out critical regions. Again, this is Z. Once again, this will be a two-tailed test. Our alpha is 0.05, so 0.025 again. And once again, this is going to be inverse norm. It's the same inverse norm as the previous one. This is going to be the negative 1.96. This is the 1.96 as we're looking at this, but this one doesn't ask for the critical values. But I got these the same way I got the previous problem. So now we're going to do the test statistic. I want to double check, make sure I didn't change something. Oh, that's a different list altogether. So mine are in lists 1 and 2. So once again, this is a 2-sample t-test. This free calculator has commercials. This will just take a second. All right, so we are going to use raw data. And let's start with our, this was 1.8, 1.8. It was 1.5, yes, 1.5. My data is in list 1 and 2. This is a not equal to, and let's do this. So here is our Z test statistic. Oops. So we have 0.9312. P-value is 0.3517, which is way, way, way bigger than our alpha. In addition, I want to point out that our test statistic is nowhere close to our critical region. And both of these, we come to the conclusion that we are going to fail to reject. The null hypothesis. So can we support the researchers' claim that the mean recovery time when treated with multivitamin is not equal to that? Nope, we cannot. Because we're sticking with the null hypothesis. All right, so let us move on. To our confidence interval with sigma known. So this is going to be a Z interval. Sorry, I'm new to an iPad. Z interval. All right, so here we go. For a study conducted by research department of a pharmaceutical company, 270 randomly selected individuals were asked to report the amount of money they spend annually on prescription allergy medication. The sample mean was found to be $17.70 with a standard deviation of $5.50. A random sample of 295 individuals was selected independently of the first sample. These individuals reported their annual spending on non-prescriptive allergy relief medication. The mean of the second sample was $18.30 with a standard deviation of $4.20. As the sample sizes were quite large, it is assumed that the respective population standard deviations of the spending for prescription and non-prescription allergy relief medicine can be estimated with the sample standard deviation values given. We're going to construct a 90% confidence interval for the difference of mu1 and mu2. Now I want to point out, when we do a hypothesis test, which is not what we're doing here, we're starting here with this assumption. And I want to point out that if I subtract a mu2 to both sides, then this is the same thing as saying mu1 minus mu2 is equal to 0. So that's where we're getting this from. This is going to be the middle of our confidence interval. So we're going to have, oops, mu sub 1 minus mu sub 2, some value. And if we're to assume that 0 is in there somewhere, then it should be going from a negative value to a positive value. Then we could come to the same conclusion. So let's go ahead and run our Z interval. I'm sorry, this is going to be not Z interval. This is going to be a 2-sample Z interval. Two-sample Z interval. So stat test 2-sample Z intervals, my number 9, maybe different number on yours. But we are not going to be using raw data. And our sigmas are going to be $5.50. And our other one is $4.20, so 4.2. So the first X bar is the 17.7. And N is 270. 270. X bar sub 2 is the 18.3. And our N in that case is 295. Confidence level in this case is 90% or 0.9. And here we go. And there is our confidence interval. So our answer is negative 1.2818 to 0.0818. And I want to point out that we are going from a negative value to a positive value. So we're 90% certain that we're going to get our 0 in there. And so here's our actual confidence interval. All right, we are on to part 2. 2 means independent samples. So for this one, we're going to be using a 2-sample t-test. So 2 samples are independent. If the same values from one population are not equal to or are not related to or somehow naturally paired or matched up with sample values of another population, we conduct a hypothesis test of a claim about 2 independent population means. We are going to assume that sigma sub 1, sigma sub 2, so the 2 populations' standard deviations are unknown. That means we're going to be using a t-distribution. You're also going to assume that they're not equal. And in math terms, that means that they are not going to be pooled. One of the options when we're doing this is to say, hey, can the data be pooled? The answer is going to be no for us, for all of them for this particular class. Our requirements, sigma sub 1, sigma sub 2 are unknown, and we do not assume that they are equal, so they're not pooled. 2 samples are independent, both are simple random samples, and they're either both normally distributed or their n is larger than 30 for both. Now here's the hypothesis. I didn't show you the formula for the z, it's pretty much the same, but we don't have to necessarily use this, but what we are going to need to do is find the degrees of freedom by it being the smaller of the 2 sample sizes. And let's get started. Lake Martin and Lake Fields are 2 large local lakes inhabited by white sturgeon. A while back, there was an environmental disaster at Lake Martin. Layla is an ecologist who wants to see if the mean weight in kilograms of adult white sturgeon now living in Lake Martin is less than the mean weight in kilograms of white sturgeon now living in Lake Fields. So we're going to go here. Oops. Mu sub 1 is equal to mu sub 2. We're going to assume that. And they're now saying that mu sub 1, they think is going to be less than mu sub 2, meaning it stunted their growth somehow. And we have the data recorded below. I've put this data into lists 2 and 3, or 3 and 4, pardon me. And you can see my 72.2 is 66.2, and the 102.9 and the 52.3. Ooh, I'll have to double check that one because that one's not zero when we get to that. Okay. So we are going to be using a t distribution for this. And let's draw our picture. You may need to pause the video to put the data into list. Mine are in list 3 and 4. You can erase lists 1 and 2, and I'll just show you what mine's going to be 3 and 4. And let's draw our t distribution. And this is less than, so it's going to be a left-tailed. And our alpha in this case is 0.05. To get that, first of all, let's find our degrees of freedom. So there are 11 from Lake Martin and 12 from Lake Fields. This means our degrees of freedom are going to be the 11 minus 1. Degrees of freedom in this case is 10. All right. So to find my critical value, I'm use inverse t. So negative 1.812. And let's find the test statistic. We are going to run, in this case, this is going to be a 2-sample t-test. 2-sample t-test is my number 4 here. We are using lists. I got to change my lists, though. List 3 for me. And list 4. And this is a less than scenario. Remember, it's always going to be no on the pooling. And calculate. So let's see what we have. There it is. So t is about negative 1.464. Our critical value we already got. T is about negative 1.812. And I can see that my test statistic is just outside of the critical region. So I'm like right there. Close, not quite there. So we are going to fail to reject. The null hypothesis. So at the 5% level of significance, can the ecologists conclude that the mean weight of adult white sturgeon now living in Lake Martin is less than nope, we can't. We're sticking with the null hypothesis. We still think that the means are the same. All right. All right, here's our next example. Dante is a human resources executive for a technology company. He is deciding between 2 types of plans for vacation allowance for the employees of the company, unlimited and traditional. Dante wants to determine for the workers in the tech industry if the yearly mean number of vacation days taken by workers with an unlimited plan is greater than that of the traditional plan. So let's write down our null hypothesis. They want to know if the unlimited is larger. Where did I see that? Is greater than. So mu sub 1 is larger than mu sub 2. This is definitely going to be a t-test. And we are going to be here. This is a larger than scenario. And the alpha that they give us is 1%. So to get my critical value, inverse t of 1 minus 0.01. Now I want to point out the traditional plan, there are 16, and the unlimited, there are 17. So that means that we're going to do our degrees of freedom is going to be 16 minus 1 or 15. Minus 0.01, comma. So I'm getting 2.6602. All right. So the second paragraph, Dante surveys a random sample of 17 workers who have the unlimited plan and a random sample of 16 workers from the traditional plan. They're chosen independently. For each worker, he records the number of vacation days taken last year. For the workers with the unlimited plan, the sample mean is 17.7 with a sample variance. Now be careful, this is the variance. So we'll have to do the square root of 44.8. For the traditional plan, the sample mean is 14.3 with a sample, again, variance 5.1. So again, we'll have to do the square root. So we'll have to be extra careful here. They are asking for the critical value. So this is t is about 2.602. Let's find the test statistic. Stat, and once again, we're going to be using a 2-sample t-test. Two-sample t-test. So this one, we are not using raw data, we're using statistics. And it says for the workers of the unlimited plan, the sample mean is 17.7. Oh, that happened the same, 17.7. With a sample variance of 44.8. So I have to do careful, the square root of 44.8. And n for the unlimited plan is 17. Oops, clear 17. The mean of the other plan was 14.3. And with a sample variance of 5.1, so we need to do the square root. 5.1. N is 16 for the traditional plan. This one is now a larger than scenario. Again, still pooled, not pooled, I mean. And we're going to calculate. So let's see what we get. So T is about 1.978. And we can see that we are definitely not in the rejection zone. So we are going to fail to reject. The null hypothesis. So at the 1% level of significance, can Dante conclude that the yearly mean number of vacation days taken by workers with an unlimited plan is greater? No, we can't. We're sticking with the null hypothesis that they're equal. All right. Let us keep going. So now we're going to do a confidence interval. Kind of like what we did before. All right, I want to make sure I didn't change my data. All this might, oh, okay, good. So 197, and this is another 197. Nope, now I have 3 197s. So now I have too many 197s. So I'm going to delete that. Delete. So 16 and 18. Well, I have the answer in front of me, so we'll see if I messed that up or not. As part of a staged rollout, a new email client was installed on some computers of a major company's customer service representatives, CSRs. One of the company's performance analysts has been tasked with estimating the difference on the busiest day of the year between the mean time in minutes spent working on email for CSRs using the new email client and the mean time. Not sure what happened there. And the mean time in minutes spent working on email for CSRs of the old email client. On the busiest day of the year, the performance analyst studies a random sample of 16 CSRs using the new and 18 using the old. And they are recorded down here. I am just going to double check my list here, just real quick. Yes, okay, good. I can stop stressing then. Quit. Oh, I know what I did. I hit insert instead of quit. That's okay. Okay, so we are going to be using a 2 sample t interval or confidence interval here. Assume that the 2 proportion times are approximately normally distributed. Let u sub 1 be the new and mu sub 2 be the old. And we're going to be using a 99% confidence level. So let's do this. Again, you'll notice my lists are in list 5 and 6. Yours may need to pause the video to put the data in. So let's do our stat tests. And we want 2 sample t interval. There it is. And this is going to be list 5 and list 6. And our level is at 99%. We are not pooling. And there we are. So our confidence interval is 1.34058 up to 76.46497. Now you'll notice we're not going from a negative to a positive. So if I were using this as a test, I would say that we are rejecting the null hypothesis because 0 is not a part of this. Well, I hope you found this helpful.